Hi, my dear class 10th students. As part of quick revision tour, we are going to discuss Introduction to Trigonometry in this video. In this chapter, we are going to discuss Pythagoras triplets, Introduction to trigonometric ratios of some specific angles, and trigonometric identities. These are the topics which we are going to cover, as well as we are going to solve some problems based on all these key concepts. You all already know that time is running with jet speed and you are getting lot of pressure from different sides. In such a scenario, knowing key concepts are really going to help you a lot. And in this chapter, you have only three key concepts. What are they? Introduction to trigonometric ratios of some specific angles, trigonometric identities. These are the only three key concepts which are there in this chapter, and we are going to solve some problems based on all these three concepts. And before proceeding further, you should recall Pythagoras theorem and Pythagoras triplets, which is really going to help you a lot to solve all the problems of this chapter. My dear students, do you know the magic of sticky notes? You can complete 14 chapters of mathematics, 14 into 2, 28. Within 28 minutes, you can complete all the 14 chapters. This is the magic of sticky notes. So please note down key concepts very carefully. As we already mentioned, let us recall Pythagoras theorem and Pythagoras triplets. See here, you might be already knowing in triangle ABC, if right angle is at B, then AC square is equal to AB square plus BC square, and this is what I think all of you know already in your previous class. Now let us mainly focus on Pythagoras triplets. See, you have here one triplet 3, 4, 5. Here 5 is the hypotenuse and 5 square is equal to 3 square plus 4 square. Let us check whether it is correct or not. See here on the screen, 5 square is nothing but 25, and when you add these two numbers you will get 25. So this kind of numbers which satisfy AC square is equals to AB square plus BC square. Such kind of three numbers or triplets are called Pythagoras triplets, and knowing this Pythagoras triplets is really going to help you a lot to solve the problems which are there in trigonometry and of course in applications of trigonometry also. Let us now discuss introduction to trigonometric ratios. See, there are 6 different trigonometric ratios. What are they? Sin theta, cos theta, tan theta. And for sin theta, the reciprocal of sin theta is cosec theta, reciprocal of cos theta is sec theta, reciprocal of tan theta is cot theta. Knowing these trigonometric ratios is very much basic and important concept. And you might be knowing already sin theta is nothing but opposite by hypotenuse, cos theta is nothing but adjacent by hypotenuse, tan theta is nothing but opposite by adjacent. And for these all ratios, reciprocals only cosec and sec and cot theta. So this is what all about introduction to trigonometric ratios. Next we have to discuss trigonometric ratios of some specific angles. So here in this class 10th, you will be learning 0, 30, 45, 60 and 90 degrees. For these angles only, you are going to learn trigonometric ratios. So sin 0 is 0, sin 30 1 by 2, sin 45 1 by root 2, sin 60 root 3 by 2 and sin 90 1. So these are the trigonometric ratios of different angles which you must and should know. Our next key concept is trigonometric identities. In your class 10th, there are only 3 trigonometric identities. What are they? Sin square theta plus cos square theta is equal to 1. Secant square theta minus tan square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. So these are the only 3 different trigonometric identities you have in your class 10th. Now let us discuss some problems based on 3 key concepts of this particular chapter And these problems are really going to help you a lot to give lot of clarity and confidence, and this is more than enough to you to perform excellent in your final exam. So our first key concept is introduction to trigonometric ratios, and let us solve some problems based on this concept. And in this first problem they have given AB, BC, but they did not give AC. So using Pythagoras theorem, let us find AC value, and you know that AC square is equal to AB square plus BC square as per Pythagoras theorem, and when you substitute the given values and simplify, you will get the value of AC is equal to 25. Now what is our main focus? Our main focus is we need to find the trigonometric ratios. What are they? Sin A, cos A, sin C and cos C. So our trigonometric ratios are sin theta is nothing but opposite by hypotenuse, cos theta is nothing but adjacent by hypotenuse, tan theta is nothing but opposite by adjacent. And inverse of sin theta is cosec theta, inverse of cos theta is sec theta, inverse of tan theta is cot theta. And one more thing you should know, tan theta can be written as sin by cos, sin theta by cos theta we can write. So let us now find sin A, and you know that for this angle A, opposite side is BC and hypotenuse is AC. So sin A is nothing but BC by AC, and values are 7 by 25. Similarly, let us find cos A. Cos A is nothing but adjacent by hypotenuse. For this angle A, adjacent is AB, opposite is BC. So we can write AB by AC, because cos A is nothing but adjacent by hypotenuse, and substitute the values, and finally you will get 24 by 25 as the value of cos A. Now let us find sin C and cos C. Here with respect to angle C, opposite side is AB, adjacent side is BC. Previously opposite side was BC, so that is what main thing you need to identify here. Now again we have the values already. So sin C is nothing but opposite. For this angle C, opposite is AB and hypotenuse is AC. So AB by AC, and its value is 24 by 25. Cos C is nothing but, for angle C, BC is adjacent. So BC by AC we have to write, and its value is 7 by 25. So this is how we can write basic trigonometric ratios using the given values. Let us solve one more problem on our first key concept. And here in this problem, we need to find tan P minus cot R, and they have given figure. But in this figure, they did not give the value of QR. But don't worry, we have our Pythagoras Kaka. He has given one theorem. So using that Pythagoras Kaka theorem, let us solve and find the value of QR. Since Q is the right angle and PR is the hypotenuse, PR square is equals to PQ square plus QR square. And when you substitute the given values, then you will get automatically the value of QR, and that is 5 centimeters. Now we have the values of PQ, QR and PR. And we also know that tan theta is nothing but opposite by adjacent. Cot theta is nothing but adjacent by opposite. And what we have to find? We have to find tan P minus cot R. So clearly see, this is angle P. Tan P is nothing but opposite by adjacent. So for angle P, opposite is QR, adjacent is PQ. So what we have to write? Tan P, QR by PQ we have to write. Next, cot R. This is the angle R. For this angle, opposite is PQ, adjacent is QR. So cot R is nothing but adjacent by opposite, means QR by PQ we have to write. So that is what we have written. Tan P is also QR by PQ only. Cot R is also QR by PQ. When you substitute the given values and simplify, you will get 0. Finally, the answer is tan P minus cot R is equal to 0. So till now we have solved 2 problems. Why? To make perfection in our first key concept. What is that? Introduction to trigonometric ratios. So that is the main aim of solving these first two problems. Now let us solve some problems on our third key concept. What is that? Trigonometric identities. And you have three identities only in your 10th class. What are they? Sin square theta plus cos square theta is equal to 1. Secant square theta minus tan square theta is also equal to 1. Cosecant square theta minus cos square theta is also equal to 1. These are the only three trigonometric identities which you have in your class 10th. Now let us solve one problem based on trigonometric identities. So here in this problem, let us take LHS and try to prove this LHS is equals to 1 minus cos theta by 1 plus cos theta. So cosec theta is nothing but reciprocal of sin theta. So we can write 1 by sin theta. Cot theta is nothing but cos theta by sin theta. So that is what we have written. Now here denominators are same, so when you take LCM you can write as shown here on the screen. Again you can write numerator square by denominator square. So simple thing we have done. Now only we are going to use our 10th class knowledge. What is the trigonometric identity? Sin square theta plus cos square theta is equals to 1. From this sin square theta you can write 1 minus cos square theta. So in place of sin square theta, we are going to write 1 minus cos square theta. That is the only one step we have done using your 10th class knowledge. After that, this 1 minus cos theta whole square you can write as 1 minus cos theta into 1 minus cos theta. Whereas in the denominator you have 1 minus cos square theta. 1 minus cos square theta you have. It means 1 square minus cos square theta. It means a square minus b square. So this a square minus b square you can write as a minus b into a plus b, or else a plus b into a minus b. So that is what we have used, algebraic identity. When you cancel this 1 minus cos theta and 1 minus cos theta, you will be left with this 1 minus cos theta by this 1 plus cos theta, and this is what the required RHS. Hence we have proved whatever they have asked us to prove. So this is how we can solve using our key concepts. Now let us solve one more problem using our trigonometric identities. So for that let us take first of all LHS and try to prove this is equals to 2 into sec A. So here you can see denominator 1 plus sin A and cos A. So this will be the LCM. So this cos A into cos A, cos square A, 1 plus sin A into 1 plus sin A, 1 plus sin A whole square. This is how we can write. Next, using A plus B whole square formula, you can write 1 plus sin square A plus 2 sin A. Now, let us carry forward this step, and you know this cos square A plus sin square A is nothing but 1, and this is what our 10th class knowledge, that too trigonometric identity formula sin square theta plus cos square theta is equals to 1. This formula now we are going to use in this step. So when you add these two, you can write 1, and 1 is already there, and remaining 2 sin A we have written as it is. And 1 plus 1, 2, you can write 2 plus 2 sin A. From this, if you take 2 common, you can write 2 into 1 plus sin A. Here 1 plus sin A is there, here 1 plus sin A is there. You can cancel them. After cancellation, you will be left with 2 by cos A. And you know that cos A is the reciprocal of secant theta. So you can write 2 into secant A. And this is what they asked us to prove. Let us solve one more problem using trigonometric identities. Here secant A into 1 minus sin A into secant A plus tan A is equals to 1. That is what we have to prove. So this is what the LHS. And we can write secant A as 1 by cos A. Similarly, tan A as sin A by cos A. Now, when you multiply this 1 with 1 minus sin A, you can write 1 minus sin A by cos A. And this we did not disturb anything. Now, from this, if you take LCM cos A, you can express this as 1 plus sin A by cos A. Now, cos A into cos A, cos square A here in the denominator, and in the numerator 1 minus sin A into 1 plus sin A. And you know very well A plus B into A minus B is equal to A square minus B square. So as per that 1 minus sin square A, we can write this numerator. Now using this trigonometric identity, you can write cos square theta is equals to 1 minus sin square theta. So here we have 1 minus sin square a. We can write it as cos square a. Now cos square a by cos square a is equal to 1, and that is what they asked us to prove in the right hand side. Now let us solve last problem using our trigonometric identities, and in this problem they are asking us to express secant A in terms of cot A. So let us take this trigonometric identity and transpose this tan square A towards right side. Then we can write secant square A is equal to 1 plus tan square A. And if you do square root on both sides, you can write secant A is equals to plus or minus root of 1 plus tan square A. Now our main focus is we want to express this secant theta in terms of cot theta, and we know tan is the reciprocal of cot, so we can write secant A is equal to plus or minus root of 1 plus 1 by cot square A. What we have done, we have written tan in terms of cot. Finally, they asked us to express this secant A in terms of cot, so we have done using our trigonometric identity. So, my dear students, as part of our quick revision tour, we have discussed three key concepts of this particular chapter, and you can see here on the screen all those three key concepts. And this problem which we have done using introduction to trigonometric ratios, these problems we have done using trigonometric ratios of some specific angles, and these are the problems which we have done using trigonometric identities. Hope you will utilize our quick revision tour in a better manner and prepare your own short or quick notes. Thanks for watching and learning. Have a nice day.